For tomorrow, you got Hills and SAS, you got Pythag, and you have your 30, 60, 45, 45, 90 rules. I'll keep saying it, even though I think at this point in the year, you guys know, don't be shocked if it's on there. Simplest radical form. You may have to factor or use quadratic formula. Okay, I'll give you a formula sheet if you need it. All right, but don't be surprised if that's on there. All right. We definitely need to go review some stuff here before I let you go on your own. I'll be here after school today if you want to come by or email me for extra practice. It's up to you. Take a look at number 1, please. Take a look at number 1, page 18. I got the airport at A, a shopping center at S, and what do I got? A factory at F. All right, let's start labeling this bad boy. Airport and factory, 6 miles apart. Airport and factory, 6 miles apart. Their distances, so the airport's distance and the factory's distance from the shopping center are 3.6 miles. So that's from the airport to the service to the shopping center, 3.6 miles. And 4.8 miles from the factory to the shopping center. And we're going to put a little service road in to make things easier from the shopping center to the highway. That connects the airport and the factory. So everyone see my service road here? From the shopping center to this road. What's the shortest possible length to the nearest hundredth? So go ahead, find my service road. Is there any way you could be 100% sure to throw down a 30, a 60, or a 45-degree angle measure in that diagram? No. If you find yourself doing that, you're getting in desperation mode. There's no way you can put a 45 or 30 or a 60 confidently in there. All right, so what type of triangle is ASF? ASF, that's what type of triangle? Just a right triangle. And what's the service road acting as there? That's the what in that triangle? Altitude to the hypotenuse. So if I have a diagram that looks like that, probably going to start thinking what tomorrow? Hills and SAS. Yes, I can't write in any angles myself, but it is a Hills-SAS diagram. And also, I should probably put another slash. Don't forget about what? Pythag, because you got 3 right triangles rocking here. You guys told me the service road was a what? Was an altitude. So I would assume you guys would go right to SAS. And you're like, oh, yeah. Hey, this is not too bad. And then you go back and you're like, wait a second. What are you going to put for segment? You're not going to do a different variable. The thing I know is these 2 segments add up to 6. That's not going to help me. So does everyone SAS? Not right now. You can't fill it out. How about Pythag? That's always an option, right? Can I use Pythag on any of these 3 triangles? It's not going to help me. Nope. So what's the only thing I'm left with? Okay, I got to use it. There's not a 4th option for me. So let's start talking hills and how that may help me out. Here we go, 12. Give me the hypotenuse. What length up here would I put in for the hypotenuse? 12. Well, we should know that. In hills, the hypotenuse represents the hypotenuse of the large right triangle. 6. It's not any hypotenuse. It's always the hypotenuse of the large right triangle. What about leg? Okay. You could have also chosen 4.8, everyone. But if you choose 3.6 here, what's this leg? 3.6. The legs are the same in hills. And now, hey, what are you actually going to solve for by using hills? Segment. And how's that going to be helpful? What were we missing in SAS? The segments, yeah. So we're using hills to get the SAS here. Go ahead, solve for the segment. I'll get back to somebody in a second. What is that segment length that we're solving for? 20, when you're ready, what's that segment length? 12. Sorry, I'm sorry. I forgot to divide by. Go one more time, Claudia. 2.16. Nice job. 2.16 for one segment. Are you gonna force me to do hills again to find the other segment? I hope not. You could, but 15. How can I find the other segment? I got 2.16 here. Just subtract it from 6, right? 6 minus 2.16. I won't ask anybody that one. Other segments, 3.84. I've been promoting SAS from the beginning, but what else could you do here to find the altitude now? Pythag, yeah. Excuse me, it's up to you. You could use SAS or you could use Pythag. I'm going to force you. I'm going to force somebody anyway. 5. Right here. Here we go. What's the segment length? 2.16. Altitude. Altitude. And segment. Always different in SAS. Yep. So Pythag or SAS, it's up to you. I don't even think I needed rounding directions here because it does come out to be 100th anyway. When you're ready, 5 again. Altitude, service road length. What'd you do, Pythag? I just don't like that last. I just don't like that last digit. 2.88. Go ahead, Caleb. How did I know that this one in particular? Actually, you know what? I got it wrong. That's why. Is that what your question was? Here's how. Well, here's I did it incorrectly, but here's why: is because it should be the segment next to the leg I use. So if I use 3.6, yep, 2.16 here. Thank you, sir. 3.84. Because that would matter if you did Pythagorean theorem. Other questions, comments? Next one. Can you go to number 5 for me with the box of chocolates? Two reasons why I'm doing this one. Number one is it's going to review your 30, 60, 45, 45. And the second reason is how can we not do a problem that just plugs in the word snugly in there. All right. So it doesn't move around. It's snugly in there. This hexagon is regular. What's the deal with that? Okay, all sides, and it tells me the sides are 3. So all sides are 3 inches now. And it's fit snugly inside what type of box? Rectangular box. What do I know about the corners? All right, here we go. A little geometry working for us. I got right angles. So that means I have 4, what type of triangles? Right triangles. And what are these sides acting as? These are the what of the right triangles? Hypotenuse. All right, we're talking good vocab now. Ooh, I'd like to know a little. That's not going to help me out, though. I need to know a little more about the angle triangles. Knowing it's a regular hexagon, is there any way you can find me possibly one angle in those triangles? And remember anything, Bella, to help us out? It's a little review here. They add up to 360, right? Everyone agree they add up to 360? The exterior angles? Okay, they all add up to 360. How many do I have here in hexagon? 6, so that means each exterior angle is going to be, 60. Here you go, kids. Ready? Outside angle, that's 60. Nice. Outside angle, that's 60. I don't think I need to do it anymore. We can just take one of them, but what type of triangle am I working with? 30, 60, 90, everyone. If you want to, I'm going to blow it up, so I don't have to keep writing in that small space. I got a 60, I got a 30, and I got a 3 on the hypotenuse. So we determined it was a 30, 60, 90. Did anybody want to use the interior angles? Remember doing that 180 times n minus 2 and then dividing by 6? All right, back to you guys. 9, here we go. Fill in the rest of my sides. 3's across from the 90. What's across from the 30? Okay, I got 1.5 across from the 30. And what's across from the 60? Okay. You guys want to use the charts tomorrow? Use the charts. If you don't, that's fine too. All right, so across from every 30 degrees, across from every 30 is a 1.5. And across from every 60 is 1.5 radical 3. What's the dimensions? The length and the width. I don't need perimeter, not asking for it. I just want to know the length by the width for the dimensions. Length by the width. Keep it in radical form for me. Oh, who do I have up now? 17. How about let's go the length for me here. How long is this side here? 3 radical 3. By, now I'm going to ask somebody to do the width for me. 3 radical 3 by, here you go, 25 by 6. Why not 3? What do I have to also add in? Because I see the 1.5 and the 1.5, that gives me 3, but I forgot to add in. Okay. This side of 3, yes. That side of 3. So it's 3 radical 3 by 6. Yep. All right, get going on the rest. Go, hold on. Somebody in your group right now, decide who's getting the Chromebook out so we can pop up the answers off of Aspen. Right now, let's go. We're not going to do this without knowing we're doing them correctly. All right, for the next 10, 15 minutes. Somebody get out 1, 2 Chromebooks. Open up. It's under this week's homework answers. Open them up. Let's go. Let's get going.